distribution. Now what is the probability distribution function of binomial distribution? The probability distribution function is p of x is equal to ncx p power x q power n minus x with the condition p plus q is equal to 1. So x varies from 0 to n. So when x is 0, the first term is nc0. nc0 is 1. P to the power 0 is 1, remaining q to the power n minus 0, that is q to the power n. When x equal to 1, we get the next term nc1 p to the power 1 q to the power n minus 2. When x is 2, we get nc2 p square q to the power n minus 2. When x is n, we get ncn p to the power n. ncn is 1, so remaining p to the power n. So p plus q is 1, so p plus q to the power n also 1. So now we have the formula a plus b, expansion of a plus b to the power n is equal to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square plus ncn a b power n, that is the expansion of a plus b to the power n. Same way we can write a plus b to the power n minus 1 as n minus 1 c0 a power n minus 1 plus n minus 1 c1 a power n minus 2 b square a power n minus 2 b plus n minus 1 c2 a power n minus 2 b square plus etc. Last term n minus 1 c n minus 1 b to the power n minus 1. So that is when a plus b to the power n minus 1. So we can use the formula for a plus b to the power n, a plus b to the power n minus 1, etc. So now what is the mean and variance and standard deviation of binomial distribution? Let us see that. Now find the mean and variance of binomial distribution. So what is the mean? Mean is equal to summation x p of x is the formula. Now summation x, what is the probability distribution function is p of x of binomial distribution is ncx p to the power x q to the power n minus x is this. Now summation x n factorial ncx is n factorial by x factorial n minus x factorial p power x q power n minus x. Now x varies from 0 to n, so when x is 0, first term is 0, x is 1, n factorial 1 factorial by n minus 1 factorial p power n 1 q power n minus 1. When x is 2, we get 2 into n factorial by 2 factorial n minus 2 factorial p square q to the power n minus 2 plus etc. plus last term when x is n, we get n into n factorial by n factorial into n minus n factorial p to the power n q to the power n minus n. On simplifying, we get n minus 1, n into n minus 1 factorial by n minus 1 factorial, p to the power 1, q to the power n minus 1. What is this? We have written n factorial as n into n minus 1 factorial. Second term also we have written n factorial as n into n minus 1 factorial, n minus 2 factorial divided by n minus 2 factorial p square q to the power n minus 2 plus etc. Last term n into p to the power 1 q to the power 0, q to the power 0 is 1. Now we will take np outside. The remaining terms we have written here. Last term is p to the power n minus 1, since we have taken n into p outside, remaining p to the power n minus 1. Now np into n minus 1 factorial, n minus 1 factorial cancels, so 1 is remaining. How we can write 1 n minus 1 c0, that is explained earlier, q to the power n minus 1 plus n minus 1 c1 p q to the power n minus 2 plus etc. n minus 1 c n minus 1 p to the power n minus 1. Last term is written as n minus 1 c n minus 1. 1 is replaced by n minus 1 c n minus 1. Now NP, what is this? What is there inside the bracket? Is the expansion of q plus p to the power n minus 1. We can see there n minus 1 c0 q to the power n minus 1 etc. Last term n minus 1 c n minus 1 p to the power n minus 1. So it is the expansion of q plus p to the power n minus 1. So q plus p to the power n minus 1 is 1 to the power n minus 1. So it is 1. So we get np. So the mean of the binomial distribution is n into p. Next we will find variance. Variance is equal to sigma square is equal to expectation of x square minus mu square. That is the formula. So e of x square minus mu square. So what is e of x square? E of x square is summation x square p of x minus mu square. So now we will rewrite this x square p of x as x into x minus 1 plus x into p of x. When we simplify this, we get the same term x square p of x. So we have written this as x into x minus 1 plus x into p of x, so that we will get the next term as summation x p of x, which is mu. So now we will separate this summation x into x minus 1 p of x, first term, second term summation x p of x, third term minus mu square. Now summation x into x minus 1 p of x, what is summation x into p of x is mu minus mu square. Now take this as 1. Now consider the first term summation x into x minus 1 p of x is equal to summation x into x minus 1. What is p of x? ncx p to the power x q to the power n minus x. Now we will expand this by taking x value from 0 to n. So when x is 0, 0. When x is 1 also, 1 minus 1, 0. Second term also 0. It starts from third term. So when x is 2, 2 into 2 minus 1 to 1. nc2 p square q to the power n minus 2. Similarly, when x equal to 3 we get this, x equal to 4 we get this. Last term when x equal to n into n minus 1, nc n minus 1 p to the power x equal to n into n minus 1, nc n p to the power n q to the power n minus n. So now equal to 2 into n factorial n minus 2 factorial into 2 factorial p square q to the power n minus 2 plus 3 into 2 n factorial p cube q to the power n minus 3 factorial. 3 factorial is 3 into 3, 3 into 2 6 and 6, 3 into 2 6 cancels. 4 into 3 n factorial divided by n minus 4 factorial into 4 factorial. 4 factorial is 4, 3, 4 into 3 into 2 into 1. So 24, 12. 4 into 3 12, so 24 12 by 24 is 2 cancels and 2 remains. P to the power 4 into q to the power n minus 4 plus etc plus n into n minus 1 p to the power n. So now n into n minus 1 n minus 2 factorial by n minus 2 factorial p square q to the power n minus 2. We have written n minus 1 factorial as n minus 1 into n minus 2 factorial, first term. Second term also we have written n minus 1 factorial as n minus 1 into n minus 2 factorial. Third term also we have written n minus 1 into n minus 2 factorial. Last term n into n minus 1 p to the power 1 n. So n into n minus 1 p square is taken outside, remaining q to the power n minus 2 as second term. Third term is this 2 factorial. Last term p to the power n minus 2. Since n into n minus 1 is taken outside, p square is taken outside. So p to the power n minus 2 is remaining. Now n into n minus 1 p square into n minus 2 c0. We can write the power starts from q to the power n minus 2. We can write this in place of 1 n minus 2 c0 q to the power n minus 2. Next term n minus 2 c1 etc. Last term n minus 2 c n minus 2 p to the power n minus 2. So this full term is the expansion of q plus p to the power n minus 2. So we get this as 1. So the term summation x into x minus 1 p of x is n into n minus 1 p square. Now we will substitute summation x into x minus 1 p of x in 1. Now variance is equal to first term, second, third as it is. Now on simplifying we get np n minus np square. Np is taken outside, 1 minus p. 1 minus p is q. So we get variance is equal to npq. So standard deviation is square root of variance. So square root of npq is the standard deviation. So now we found out mean and variance of binomial distribution.